All right, so in this particular half-life problem, the problem states that the half-life of potassium 42 is 12.4 hours, and it says how much of a 100-gram sample is left after 62 hours, okay? All right, so to do this, let's go ahead and focus on what's being asked of us. It asks for how much is left over, not how much has decayed, so differentiate between the wording as you practice. The function for half-life to find the remaining sample that's left over is n of t. And naught here is your original amount, k is your decay rate, and then t here is the time elapsed. So k naturally is ln of 1/2 divided by t half-life, and ln of 1/2 on your calculator will give you a negative 0.693. However, in my work here, I just wrote 0.693 because the negative sign is already in the original statement. So make sure that you don't plug in another negative, otherwise you might go a negative times a negative makes a positive. So the exponent has to be a negative because this is a decay problem. Okay. So here I'm just going to carry the function down. N of t is equal to n naught times e negative kt. I'm going to substitute in k for ln of 1/2 divided by t half-life. So I'm going to substitute out k. Hence the function gets carried down. So here all I have to do is, in order to find n of t, I need to know what the starting amount is, or the starting sample, which is given as 100 grams. T half-life is given as 12.4 hours, so this particular potassium 42 splits every 12.4 hours, okay? And then how much time has gone by? The problem says 62 hours, so all we have to do is plug and chug now. N naught is 100 grams, that's how much we're given to start. Again, ln of 1/2 is just negative 0.693 here. Well, what is the half-life time? The half-life time is given as 12.4, so once again, every 12.4 hours, the substance splits in half, and it splits in half, okay? And then how much time has gone by? 62 hours. And if we simplify this, hours cancels out. And then if you take 62 divided by 12.4, you'll get 5. So this is where the 5 comes from, okay? So again, nothing has changed on the right side except for the fact that there's a 5 there. So if you take 65 divided by 12.4, you get 5. That's entirely up to you. You can simply take 0.693 times 62 and then 62 divided by 12.4. I just went ahead and just took 62 divided by 12.5 to see if there's any whole cycles, which it happens to be 5. All right. From here, really it's just calculator work. So if you do 100 times E and raise it to the negative, in parentheses, 0.693 times 5, you'll get 0.03127. And if you simplify that, you get about 3.127 grams. So that's how much is still left over from a 100-gram sample after 62 hours. So N of t is how much you still have left after 62 hours. The other way to do this problem is to just apply this particular function. Is also for half-life. It just does it without raising it to the e power, okay, or e to the negative k t power, excuse me. So here N of t once again is how much you still have, and naught is your starting amount. And then this is dividing by 2 to this power. So t divided by t 1/2 is the number of cycles that has occurred. Okay, so t divided by t 1/2 is the number of cycles, right? This is how much time divided by how much does it split. So therefore, that's the number of cycles that has taken place. So here I'm just going to plug and chug. And naught is 100 grams. And then 2 is, because this is half-life, and then 62 hours divided by 12.4, it will give you 5. So really, you're raising the 2 on the bottom to the power of 5. Okay, so 100 divided by 2 to the 5th power, and if you do that correctly in your calculator, 2 to the 5th power is 32, and then you take 100 divided by 32, which will give you with about the same answer of 3.125 grams. Okay, so there are a couple of different ways to do this particular problem. So in order to find how much is left over, it's pretty light work. I kind of like the right side. I think it's a little easier to do, but that is entirely up to you. All right, stay nerdy, don't be whack.